Okay, so for this section, we are going to be looking at the section review number 2, and the problem says a mixture of gasoline vapor and air is placed in an engine cylinder. Okay, so just like a car engine, or sorry, car engine cylinder, we have some amount of air and fuel mixture in here, and I'm drawing it just kind of cartoony just for simplicity. And there's a piston at the top that is going to be pushing on that. So the piston will kind of be like right here, and it'll essentially be a little flat piston that will be pushed down on, as it says, because the piston has this amount of area and is displaced inward. So the piston is going to be pushing down on the gas. If this much pressure is placed on the piston, how much work is done during this process? Is work being done on or by the gas mixture? So the first thing that I want to talk about is this part, is the work being done on or by the gas mixture. Now, remember that the gas wants to expand as much as it can. So the fact that it is being pushed on means that the work is being done on the gas, not by the gas. Okay, so once we've got that, then we simply have to use our equation of work equals pressure times change in volume. And essentially we have we already have our area, so remember that pressure equals, well, here it says, what is the question? How much work is being done during this process? So we've got our pressure, and then we just need to find our change in volume. So pressure is already given as 9.5 times 10 to the 5th pascals. And then we have a change in volume. So that's kind of the question that we're needing to answer here to find. So we have the area, and we have it displaced inwards. So that means that we are given this area of the piston, and we are given how far it's displaced inwards. In other words, we have a volume of a cylinder right here if we multiply those out. So remember that the volume of a cylinder is equal to the area times the height, which is equal to pi r squared times the height. But of course, we're already given the area, so we don't even need to use this. So we just need to multiply area times height, make sure that everything is in meters, which it is. And so we just go ahead and take this pressure, and we multiply it by, so we get 9.5 times 10 to the 5th pascals for pressure. And then for volume, we get area times height. So we get the area of 7.4 times 10 to the negative 3rd square meters times 7.2 times 10 to the negative 2nd meters. And that multiplication will give us the volume, so that will give us the work. That turns out to be around 500 joules of energy. So I won't write that, well, I'll write it down, 506.16 joules of energy. And that's it. That's all that we have to do for this problem. So the first section should be fairly straightforward on how to work some of these problems.